Good day, ladies and gentlemen. Today we'll be jumping into our study of sampling distributions. And before we can get into that, we have to talk about what parameters and statistics are, what they are, why we use them, and then we have to look at what is this sampling distribution thing all about. So to start, we're going to be focusing a lot of our energy on statistical inference. So we've seen these words before. Inferring something means we're going to draw conclusions from our sample about the wider population. One thing you have to understand is that different random samples yield different statistics. If I have this population and I take a sample out of it, we look at data, and then we can use that data to make inferences about the population. But what you have to understand is that different samples will have different data, thereby giving us, for instance, different means within that sample. So what do we do with that? That's what we're going to look at. A statistic is a random variable because it takes on numerical values that describes the outcome of the random sampling process. So we're going to be using stuff that we dealt with, probability distribution stuff that we looked at in the previous chapter. Let's talk parameters versus statistics. When we draw conclusions about a wider population, we have to make sure we understand whether or not these numbers that we're using are from samples or from populations. A parameter is a number that describes a characteristic of the population. This we usually don't know, guys. We usually can't collect data from the entire population. It takes too long, it's too expensive. It's just not physically or feasibly possible. A statistic is what we're usually dealing with. That is coming from a sample. The value of the statistic is computed directly from the sample data, and we're using this statistic to estimate or infer an unknown parameter. We've seen and dealt with some statistics and parameters. X bar, that is a statistic. Mu, that's the population mean. S, that's the sample statistic for standard deviation. Lowercase sigma, that is the parameter, population parameter for standard deviation. It's important to understand which is which and when it's appropriate to use one versus the other. S and P. S, statistics. Statistics come from samples. P, parameters come from populations. S with S, P with P. There we go. So here we go again, mu versus X bar. A lot of times in this section, we're going to be dealing with some parameter. Not necessarily mean, not necessarily standard deviation, but some fraction of the total data. And we're going to use P hat to represent our statistic, to represent P, the population proportion. We'll see examples of what this means for us, but we're going to use P versus P hat quite a bit. So I mentioned this a minute ago. There's sampling variability. When we repeatedly collect a sample from a population, we get different means, different standard deviations, different numbers usually, because these samples are randomly taken. So these samples come from different places in the population, and from each sample we're collecting data. And what does that mean? What does it tell us? What can we infer from it? And that's what we're going to be looking at. And in the next video, we're going to start to look at what happens as we sample a whole bunch of times.